All right, welcome back. This is Expedition STEM. We're here at ISEF. I'm here with Simone, and right now we're going to check out some cool robotic stuff. So what kind of projects do you have here?
Sure. So this project is called a novel haptic actuator for soft robotics, utilizing soft robotic pneumatic networks, a closed-loop control system, and an electro-pneumatic control board to restore an operator's sense of touch. So kind of what I'm doing in this project is addressing the lack of haptic feedback in minimally invasive robotic surgery. So robotic surgeons currently operate without the benefit of their sense of touch. And this novel soft robotic gripper is the first prototype to allow surgeons to control the motion of the robot with their own natural hand motion, and then simultaneously feel the pressure that the robot is applying to an object back on their own hand.
So why would a surgeon want haptic feedback?
Sure. So there's one product on the system right now, which is called the Da Vinci surgical system, and that represents 100% of the market share for minimally invasive robotic surgery. And surgeons operating with the Da Vinci surgical system only have visual feedback, so they offer absolutely no touch feedback. And unfortunately, since 2000, there have been significant related malfunction adverse events that have been reported, including 1,391 injuries and 144 deaths that have some way been attributed to a lack of touch feedback.
Wow.
So clearly it's a pretty big problem. And there were actually two meta-studies that were published, one in 2013 and one in 2015, that stated that a 67% improvement in surgeon procedure could be reached if haptic technology could be developed to add back a surgeon's sense of touch.
Wow.
So the first element that this video will explain is the grasping control. So on the left-hand side, you can see that's the element that would hypothetically go inside the body. And as the finger and the control glove on the right side moves, you can see that the left side moves to match the same position. And the second element is the haptic or touch feedback. So there's a force sensor on the end of that pink actuator. And on the right-hand side, you can see the haptic actuator inflates to relay a pressure back to the user. That's the same as what the pink actuator is applying to an object.
Wow. And have you shared this with any doctors, and what did they think about this?
So there's kind of been just a general sentiment of excitement. You know, doctors definitely realize who are doing this surgery that the lack of haptic feedback is an issue. I actually had the opportunity to use the Da Vinci surgical system. It was a while ago.
Did you operate on anybody?
Thankfully, no.
Okay.
They gave us Tootsie Rolls.
Okay.
Not people, which is probably a good decision.
Yeah.
But I very, very distinctly remember accidentally slicing through a Tootsie Roll and having no idea that I'd done it. And the idea that someone could be operating inside of you and having absolutely no idea how much pressure they're applying to objects was kind of alarming for me.
Right.
And was definitely a very big inspiration as to why I did this research.
Okay. And what are some of the components of your demo? So I see a lot of little wires and circuit boards.
So this is the control board. It's actually an open source kit of parts developed by Harvard University. And I can show you actually kind of how this works by inflating a balloon. So let me just turn it on here. So we've got voltage going in now, and in about 3 seconds the balloon will inflate and then start doing something called pulse width modulation, or PWM. So it's inflating now, and this solenoid valve is open. And then the pulse width modulation is what allows me to maintain a certain pressure. So a valve will open and close relatively quickly, and instead of just letting airflow in or letting airflow out, this allows it to maintain a level of pressurization. And the pulse width modulation rate is actually what's being changed when I'm using the operator control glove. So if I bend my finger further down, the pulse width modulation will let the valve stay open for longer rather than closed and allow more air to flow in and letting it curve more. But if I bend my finger backwards, the opposite will happen. So the valve stays closed for longer and air flows out for longer.
And so right now there's no haptic feedback out there right now.
Feedback.
So, and you're going to be going to which college is
Harvard.
it?
Harvard next year.
I think I've heard of that. So, are you planning on continuing this research?
Yeah, I really hope so. I think I'll be able to transition right into doing the research once I get there. And Harvard actually has a simulated surgical setting where you can practice the removal of cancerous tumors or simulate cardiac surgery. And those are really two great applications for this technology. So having the access to kind of a setup like that, I think, will be really great for me to continue moving forward in this project.
Awesome. And what are some of the things that you want to see, like, that you can change in the future, like anything you want to improve on? Or
I definitely hope that incorporating this technology into robotic surgery overall will help prevent more people from becoming injured. And actually what can happen if a surgeon does make a mistake with the type of end effector or tool on the end of a robotic surgical device right now is that the procedure will have to be converted to an open procedure, which kind of defeats the whole purpose of having minimally invasive robotic surgery to begin with. So hopefully technology like this can help kind of protect people and I guess prevent from having surgeries converted to open procedures.
Awesome. And you won the New York City Science Fair,
Yes,
and that's why you're here at ISEF, right? So we wish you luck at ISEF.
Thank you very much.
And congratulations on what you've already done.
Thank you.
It looks amazing. I hope you're able to get this into the hospitals, because it seems like an important part of the surgical procedure.
Yeah. Thank you.
Awesome. Thank you very much. And we'll see you at the next one.